Hi, I'm Colin Walls, and I'm here again to talk about embedded software. Today I want to think about a matter which concerns embedded software engineers from time to time and can be some interesting challenges. And that is the matter of accessing device registers in C. Now, by a device register, I mean you have an external device to your processor and you need to control that device by putting values into registers and reading values from them. Now, as an example, let's think about a serial port, a serial controller. This may have, say, an 8-bit register, and the fields might look like this. So we see there is bits 0, 1 and 2 set the baud rate, and they have various possibilities. Then bits 3 and 4 set the parity, bits 5 and 6 are not used, and bit 7 enables the interrupt. So you need to be able to write to each of those bit fields and probably read back from them as well. Sounds pretty straightforward. How do you go about doing it? Well, you need to map onto that register somehow, and that's another matter. There's various ways of achieving that. Broadly speaking, you have a pointer to it and dereference the pointer. There are 4 key issues, though, that you need to get right when you're working with device registers. The first one is the word size. How big is the register, and therefore what data type do you want to assign to it? Because C will only work with data which has a type. So if it's an 8-bit register, you might assign it to be an unsigned char, for example. It's a 32-bit register, it might be an unsigned int. If you're using the more recent versions of the C language, then of course you have data types that specify the bit size of the word, and that's fine. Second issue is endianity. As soon as you have registers which are more than 1 byte long, you start wondering which way round the bytes are in the register, and are they the same as assumed by the CPU you're using, and hence the compiler you're using. You just need to find out, basically. If they're the wrong way round, then you map them accordingly. But that can be very confusing. And a device is likely to be semi-dedicated to a CPU, so maybe you can just assume they match, but check. Third issue, the keyword volatile. The keyword volatile in the C language is designed to help you for this situation, because if you access a register continually, in other words, you keep polling it to check whether there's some data or something in it, the compiler will say, oh, right, I can optimize that. So what I'll do is I'll read the register once into memory and use that copy from then onwards, which is not what you intend at all. So if you declare your register as being volatile, then it tells the compiler it must access it explicitly every time you want to gain access to that register. Very straightforward. Lastly, how do you access the individual bit fields inside the register? Well, the obvious facility to use in the C language are bit fields. Bit fields are integers of arbitrary bit size inside a structure. So it seems the logical thing to do would be to create a structure with bit fields of the appropriate size, and then map that structure, map a variable of pointer to a variable of that structure type onto your register. That could work quite well. On the other hand, it might not. 2 reasons why it might not work. Firstly, you may have a register on your device which is write only, and you won't be able to read back from it. And the way the code is written by the compiler to handle bit fields will assume that you can read an OR in data and write it back again. The other thing is what order those bits get mapped. The C language doesn't say. Your compiler may map them in the order that you need them for your device, but it might not. So use bit fields with great care is all I can suggest. It's probably much better to code it carefully yourself to make sure that you're ORing in the bits into a copy of a variable and then writing the variable out, and you know the bits are in the right places. A few things to think about, but mastering device registers is something which embedded software engineers really need to do. So that's all for today. I hope that's useful, Look forward to seeing you next time. I'll be back again soon with some other aspect of embedded software. Bye for now.